Hey there everyone, welcome to day 2 of our self-paced lesson 4.0. Yesterday we talked about three-dimensional objects and we explored some of the terms like edges, vertices, faces. Today we're going to continue with part 2 of this lesson. So if you were not here yesterday, I'm actually going to ask that you do that lesson first and then do this lesson, the part 2, as homework. Okay. So let's go ahead and get started with part 2. Now, at the beginning of lesson 1, we did talk about the term nets, and I said that we would at some point get into what exactly that is. So to sum it all up, three-dimensional solids can be flattened out into geometric nets. So if we imagine a 3D shape, if we were to break that apart, kind of like you would with a cereal box, you take that 3D shape, break it apart. When you have it laying flat, that flat object or that pattern is called the geometric net. Okay, so moving on forward to the definition of a net. A net is a flat figure that can be folded to form a closed 3D object, also called a solid. So now if we think of the opposite process of, instead of breaking down a box, we think about what shape and what pattern is going to build to make a box. That is the opposite of what it would be like to break apart a net. So there cannot, this is very important now, with nets there cannot be any gaps or overlapping. Packages or boxes in the real world are similar to nets. However, those do have overlaps, and if you think about the reason why, it's because they need to have the glue to keep its shape. So nets do not have overlapping. Real scenario boxes and packaging do have some overlapping. Okay, moving forward, we do have a quick video that's linked down below in the description. It says video 1. In this video, you are going to see how a net folds to become a 3D figure. So this video is about 6 to 7 minutes long. You'll see different shapes that we've talked about yesterday. I do want you to take your time with it and watch the video all the way through, get an idea of how these 3D objects break apart and also how they are shaped together to make that 3D object, going from flat to 3D and from 3D to a flat net. Pause the video, click play in the description below for video 1, and then come back and continue. Alright, welcome back. So hopefully from that 6-minute video you saw the different examples of the 3D shapes that break apart and form the 3D objects. Remember, when they're broken apart, they are called nets. And obviously when they are put together, they are identified by their 3D shape name. So, 2 of the most common types of 3D solids are rectangular prisms and pyramids. A rectangular prism is a solid with 2 bases and rectangular sides. A pyramid is a solid figure with 1 base and triangular sides. Please take a couple minutes to go ahead and write these 2 definitions of each in your notebook. So again, you're writing the definition of a rectangular prism and the definition of a pyramid. Pause the video and come back. Okay, welcome back. Here down below we see that we have special types of rectangular prisms. So even though we just said that is one of the most common, it kind of breaks down a little bit further. And one of the special types is a rectangular prism, or also known as a cuboid. And a rectangular prism, or cuboid, is a prism with rectangular bases and rectangular sides. So this one has both the bases and the sides as rectangular shapes. The next special rectangular prism is a cube, and that one we're more familiar with. If you think about a Rubik's Cube, it is your basic 3D shape with all faces being congruent squares. Now if we think back to last week when we've talked about congruent triangles, we know that congruent means for 2 shapes to be the same. So this is a cube with 6 congruent squares. Go ahead and pause this video, add the definitions of these 2 special types of rectangular prisms, and come back when you are done. All right, welcome back. Moving on forward, we have 3 examples here of nets that form rectangular prisms. Now, taking a look at the layout of these patterns, we see that there are a total of 6 congruent squares, right? All 4 sides of these squares are congruent, and all 6 of those squares are congruent to each other as well. So we know from this last definition that we just did that this is going to form a cube. Now, these are 3 examples of a total of 11 possibilities. So, if you have Post-it notes, I'm going to ask that you get your Post-it notes out. You are going to attempt to try to find the other 8 designs that form this rectangular prism, the cube. Okay? Now, as you work through this, you can use those Post-it notes and you can use the sticky sides to try to form that 3D shape. If you do not have Post-it notes, you can just use your pencil and your notebook to try to draw and imagine those shapes folding up. When you are done with those additional 8 nets, I'm going to have you continue back into this video and check the other 8. You are going to score yourself and see which of those you got correctly. So go ahead, pause this video, try to find the other 8 examples that create the cube. Then when you are done, come back to this video, check your work, and resume the lesson. Okay, if you are continuing this video, it's probably because you are done with your 8 nets that you just drew. Now, as you drew those nets, just make sure that they do not have any overlaps or gaps. If they do not, chances are your nets were correct. And down here below, we see that we have all 11 shown. So if by chance you didn't have one of these, or if you didn't get all 8 correct, you can correct yours and add any of the nets that you were missing. All right, welcome back. Up next, I'm going to have you answer these following questions in your notebook. The first question, what did you notice about all the nets for a cube? Go ahead and go back a few seconds to the last slide. Look at numbers 1 through 11 and go ahead and mention anything that you notice about them. The next question, what do they have in common? Make a list of at least 3 things that you notice that each of these nets have in common. Your third question is going to be to list 3 differences. If you have more than 3 differences or 3 similarities, go ahead and feel free to add as much as you can. You can pause this video, answer those questions, and then come back. Okay, welcome back. Now, last but not least, to summarize this lesson, I'm going to have you complete the Geogebra activity, Exploring Nets of Geometric Solids. This is linked on our daily doc. It is also linked down below in the description. So go ahead and make your way over to that activity. Please try to complete your work and submit it. If you are having a hard time submitting, you can take a screenshot of your work and email it over to me.